lot to cover on codes, standards, and rating systems. And so we break it up, and I'm going to be doing the first part today, and Stet is going to continue this on Monday. So today I'm going to be covering more about rating systems, which includes LEED, the Living Building Challenge, and WELL. So what do I mean when I'm talking about standards and rating systems? So I kind of see standards as the floor and rating systems as the ceiling. So one of the ways to think about that is what's the worst we can do? What's the best we can do? So let me break that down a bit, and you can see from this screen before I move it, there's a lot of them out there, and I've only done some screenshots of a few as examples. So what do I mean by this difference? Codes and standards, these are the rules that this is the floor. This defines the worst building that you can legally build. And so if you ever hear people say they're bragging that, oh yeah, I met Title 24, it's like, well, you kind of had to. So that's not anything to brag about. Now you might hear people say, we beat Title 24 by a certain percent. And that is a more appropriate way to phrase your performance. So we're going to be talking more about these codes and standards on Monday. But today I'm going to be focusing more on the incentives, what I call the rating systems. So this is where the rules encourage you to do better. It's how high can you go? How much better can you do than standard practice? And there's a lot of different systems out there. What we're going to show is that these rating systems also bring the floor up. So let's start with LEED. Now, a lot of you have probably heard of LEED. It's been out there for a while. LEED stands for Leadership in Energy and Environmental Design. And I want to note that LEED is not the only rating system out there, and it also isn't the first. Take a look at all of these icons. So actually, the first one was developed in the United Kingdom, and it was called BREEAM, and that was first launched in 1990, and it's actually the model for a lot of others that followed. So whereas that one was the first one, LEED has actually gotten a lot more attention, but there's a number of others out there from different countries, for different applications, for different building types. Today, I'm just going to focus on 3 of these: LEED, the Living Building Challenge, and WELL. And then I'll give you a brief introduction at the end about some of the newest ones that are out there. So let's unpack LEED a bit. There is a lot going on in this slide right here. The first thing I want to draw your attention to is the top bar, the fact that it's not just one. When you talk about LEED, it's not just one rating system. Now, it used to be, when it first came out, it was called LEED for new construction. And that has now been replaced with this first rating system called LEED BD&C, which is Building Design and Construction. Now, even that one, though, isn't just one system. It is all for new construction. You'll see that there are 8 subsystems below that. But they're all for new construction, and some of them are modeled for different kinds of building types, like schools and retail and healthcare. But I particularly want to point out the second one on the list here, which says core and shell. And that's something that is designed more for spec buildings, where there's one group of design professionals and contractors and builders who are just doing the basic core and shell of the building, the envelope, the basic services, and then it gets handed over to the tenant. So the second system on here, ID&C, which is Interior Design and Construction, that's meant to be paired with core and shell. So that's intended for tenants who are coming into an existing building, and they don't have control over everything. But what they do have control over, they may set a really high bar, and they want to be able to get a LEED rating just for their work. Now, the third one, operation and maintenance, that's a really important one. That's also in recent years gotten broken down into all of these subsets. It used to just be called LEED for existing buildings. That's the first name on there. And then it was called LEED for existing buildings and operation and maintenance, and it was nicknamed EBOM for EBOM. So if you ever hear people referring to EBOM who have been on for a while, that's the one they're referring to. And this is really important because I want to point out that this is the only one of the 5 rating systems that are actually about the building as it's in use. And everything else is about intention. It's about how did you design the building to perform well? How did you predict that it might perform well? But EBOM, or the operation and maintenance, is really the only one of these 5 systems that is going to require operational data. And so that's really important. Now, these other 2 are a way of, the first one, neighborhood development, is a way of creating a system that really changes scale. And then homes for residential up to, I think it's 8 stories high. And that one actually has more prerequisites than any of the others. So now I want to draw your attention to the second bar, the credit categories. This has also expanded over the years. This used to just be 5 different categories, and now it's expanded to more. So the way LEED is organized is in terms of prerequisites or mandatory measures, and then points. And these are all grouped into these different categories so that you can focus on what aspect of performance that you want to address. And then depending on how many points you get, then you get this different level of certification. Certified is almost the same as codes at this point. Silver, not so hard. People just, people kind of don't pay much attention to that anymore. Gold and platinum is really where you're raising the bar. Are there any questions on this? I'll pause for a moment. Okay, and feel free to please use the chat box if you want to add questions along the way. So when LEED was first happening, they were both developing the rating system, they were teaching people about the rating system, and then they were the same organization that would go out and say, okay, you want to certify your building, we're going to go out there and make sure that all of your, everything you said was happening is actually happening. And as it grew, they were kind of feeling like it was getting a little incestual, so they broke into 2 organizations. So the U.S. Green Building Council, which is the organization that started LEED and is still very strong, still develops the LEED rating systems. They do a lot more in terms of education and conferences and developing case studies, all kinds of other things. But there's this new organization called GBCI, the Green Building Certification Institute. So this is to try to have a little bit of separation for the third-party organization that will go out and then certify that your building did meet all of those requirements. And once GBCI was developed, turns out that a lot of other organizations took advantage of this system. And a lot of other organizations are now using GBCI as the independent third-party organization for certification. So I'm going to be talking about LEED. I said I'm going to be talking about WELL. In the upper right is a really important one. GRESB is the Global Real Estate Sustainability Benchmark, and it addresses large corporations that have a lot of buildings, a lot of assets and portfolios, and it's really great to be trying to create benchmarks for that high level, because once they reach to that, it's going to affect a lot of buildings at the same time. So that's a huge scale. The next ones do the opposite. They really just kind of break it down into very particular focuses. So peer is, well, let me start on the left. Park Smart. This is just as it stands, it's about parking structure management. So it's really focused. Peer in the middle right, that's the first rating system that is just about power system performance. On the bottom row, sustainable sites. That's the one that is jumping scale in terms of looking more at land development and management and sustainable landscapes. EDGE, I don't know a lot about that one. That was developed by IFC, which is the International Finance Corp. It's part of the World Bank, and it developed its own software, trying to make it faster and easier and more affordable to brand green buildings. And then the bottom right, True, that's all about zero waste. So it's focusing on waste output and resource life cycles. So it's very focused. Now, a thing I want to mention, just to kind of help you with language when you're out there talking with people, that buildings get certified, but people can get accredited. So sometimes I hear people say, "Oh, well, can I get certified?" No, but you can get accredited. And there used to just be one accreditation, LEED AP, but now as LEED has gotten bigger, the people accreditations have also gotten larger. So LEED GA, the one I've listed on top, Green Associates, that's a new one, and that's the entry level. So students often go for that one. It does not require professional experience. It's really just based on knowledge. If you then want to do the LEED AP, which was the title for the original accreditation for people, they now have broken up into 5 different specialties that align with those 5 different rating systems. And so for each of those, you take exams and you also have to have professional experience. And then the highest level of accreditation is LEED Fellow. And you need to be nominated for that. It's very prestigious, and it's really aimed for practitioners who have been leaders in the field and have been doing a lot to not only in their own practice, but really to move the field forward. Okay, so LEED in its early years got a lot of criticism. And I think rightly so. There were a lot of problems with it. It was really started with an aim for changing our language, changing our focus, transforming the market. And without a doubt, no matter what criticisms are out there about LEED, it has transformed the market. So for that alone, it should get a lot of credit. But it listened to a lot of the early criticism. And the current version is LEED version 4, which I'm going to show you in a minute. But LEED 3.0 is really when a lot of the changes took place to address those early criticisms. One, as the LEED systems grew, they wanted to harmonize and make things a little bit more consistent. But more importantly are the second and third. So the second one, it was felt like, you know, the points, there wasn't a lot of discrepancy. Energy efficiency was you get the same point for energy efficiency and the same point for having a bike rack if you were in an area that people couldn't even bike to, shouldn't be the same. So they developed a whole list of environmental impact categories such as climate change and resource depletion, et cetera. And they did a lot of analysis to make sure that each of the points were given for what matters most. And then the third category was really interesting. There was a lot of criticism about having one system that applied for everywhere. And there really wasn't any regional differences about, well, maybe water quality is particularly important here, or maybe air quality is, or, you know, in a climate like California where we have a lot of droughts, maybe water conservation is more important. But you can't really have a different system for every little city and region. So they did this really interesting thing where they did this regionalization by creating regional chapters, councils and affiliates where people with different expertise. And then for a project-specific location, 6 of the LEED points were identified as high priority for that region. And if the project earned one of those credits, then they got an extra point. So it's kind of like extra credit. Now, our current version of LEED is LEED v4, which was officially launched in late 2013. And that was the version that had the most rigorous changes. And I am not going to take time to go over all of these, but this is a slide and you're not going to be tested on what's on this, but this is kind of an overview if you want to go back to it to see what some of those changes were. What I do want to talk about, though, for a little bit is the two things identified in red, which is the environmental product declaration and the health product declarations. And these are really important because they're part of a larger movement that we're calling the transparency movement. I'm going to show you some things later in the lecture that are also part of this movement. And the idea here is that if we can just be more transparent and inform design professionals what's actually in their products, they can make informed decisions. And then it also motivates the manufacturers that, hey, if you want to get a credit for people using your product in the building, you have to have an EPD or an HPD. And that means that if you need to be transparent, you might want to pay a little bit more attention to what's actually in your product. So the EPDs are basically a report that summarizes what comes out of a life cycle analysis. So it's all the environmental impacts from the harvesting of the material to the transportation to the manufacturing to its disposal. And the HPDs include all of that plus the effects on human health. So the HPDs are a lot of what Sarah was talking about yesterday. So where's LEED heading? That I talked about how there's been this LEED v3 and then LEED v4, and the whole idea is that this should be a constantly evolving rating system where as we become more educated, as technologies become available, as our ability to simulate and predict performance becomes available, we're continuing to raise the bar so that we become net zero at lower levels of certification, and ultimately things become not just about minimizing the negative, but become regenerative, where you're actually trying to reverse the damage and have a net positive impact on the environment. And what's happening as the bar gets raised for rating systems, they're lifting up the standards along with them. And I think that has been really important. And that's where we have a relationship between the floor and the ceiling. So the rating systems are raising the ceiling and they're pulling the floor up with it. So I'm going to pause for a moment here before I turn to the Living Building Challenge. And if anybody has any questions, you can go ahead and type that in. Just take a minute. I don't see any yet. Anything? Okay. So let me move on now. What I want to talk about, when was V4 established? Thank you. It was in late 2013, and then it was phased in. So in late 2013, people could start applying for being certified with the higher bar, and then at this point, that's the only one that's available. So whenever a new version comes in, there's always an overlap in terms of which one you can do. Thank you for that, Olga. Okay, what are the benefits of being LEED certified? That's an excellent question, Richard. Thank you. There's a lot of them. Sometimes it's just bragging rights that an organization wants to show we're environmentally conscious. We want to say to the world, hey, we did a really good building. A lot of people build high performance buildings and they don't need the rating systems. They're just doing it because that's what's right. There's also a lot of evidence that people who are selling buildings, who are renting buildings out, actually get higher price and higher rents for buildings that are LEED certified. There's also a lot of concern with owner-occupied buildings, people who are paying you know, follow the money, people who are paying the energy operating costs and paying for the people, that if a LEED building has improved energy performance and better performance for the people, that might have financial benefits. Also for building owners, recruitment and retention of employees is a really big deal. And the quality of the workspace has been shown to really affect that as well. So thank you for those questions. Tax credits or other incentives. Great question, Maya. That's the last one I'll take right now. I don't know. I don't think there are. I know there used to be tax credits for things like putting solar on your roof. I don't know if we have that anymore either. So I don't think would be tax credits directly related to the certification itself, but it may be for other things that you do and put into the building. Great questions, everybody. All right, so the next thing I want to do is talk about the Living Building Challenge. The Living Building Challenge was put out by the International Living Future Institute. Some people have called it LEED on steroids. So it's a much higher ceiling, if you will. And it uses the metaphor of the flower. It's because everything's based in nature and rooted in place. I have to say personally, I've always had a little bit of problem with the idea of a flower because I don't have a problem with flowers. I have a problem with flowers as the metaphor because durability is really important and flowers are not very durable. So I'm not sure about that. But anyway, that's not that important. Here's what's really important. The most important differences, and this is a classic exam question, wink, wink. The most important differences between LEED and the Living Building Challenge are that while LEED has a combination of mandatory measures and point chasing, for the LBC, everything is mandatory. So you have to do it. And that's kind of interesting. The other thing that's really important, whereas with the LEED systems, I said that the only one that requires performance measurement is the LEED for existing buildings. Everything else is about intent. But LBC is only about actual performance, that you have to monitor your building for 12 months after occupation to get certified. So no matter what your intent is, you can't even get certified until you've had all of that data. So its organization is actually a little bit simpler. It has, like LEED, it has categories. They call those petals because of the metaphor of the flower. There's only 20 items, or what they call imperatives. They use the word imperatives because it's all mandatory. You have to have all 20 in order to get certified, but they do allow you to get partial certification called petal recognition if you satisfy only 3 of the 7 categories and at least one of them being energy, water, or materials. So in brief, I just wanted to show you that this table, you can look at it on your own with either the PDF or the recorded video. I think what's really cool here is that the entire, without, of course not the details, but the entire structure of the Living Building Challenge is all embedded in this table, where the imperatives are listed on that far right column. The 7 petals or categories is the far left column. And then the 3 middle columns are these scales, these different typologies that can be applied to. So not all imperatives apply to all typologies. And then the orange bars represent this idea of scale jumping. So for example, maybe you have photovoltaics, but you're doing it on the community scale because that makes more sense than on each building. And so there's a way of jumping across scales. So let me just give you a few examples of some of these imperatives. The ones that I think really set a high bar or are most relevant to the things we're talking about in this class. Any building that gets Living Building Challenge certified has to be net zero, but now called net positive water. So this means that all water must come from captured rainwater or closed water systems where you're cleansing the water, gray water systems. We talk a lot in this class about net zero energy, which is also now called net positive energy. And we've talked about that. This is where on a net annual basis, you are generating at least, but in fact now more than you're actually using. And then Sarah referred to the red list. This is probably the hardest imperative to meet. And this is where there's a really long list of chemicals that you cannot have in your building and even on the job site while you're constructing the building. So I've heard from practitioners that this is really the hardest bar. Now, two more that are really interesting that I wanted to share with you. One is called the beauty and spirit imperative, which really speaks to the heart of the project, and that it suggests this idea that every project should have some features that are solely intended for human delight. Now, how would you measure something like that? So it's interesting when there's different ways. Some people have actually used the CBE survey as a way of getting occupant feedback to measure this. But when the Living Building Challenge was first being launched and talked about, one person made this wonderful suggestion that the way this imperative should be measured is in the following way. The project should make 1 in 50 people smile, 1 in 100 people laugh, and 1 in 200 people cry. Now, of course, documenting these statistics would be very difficult, but when's the last time you even heard someone talk about the built environment in this way? And then one of the last imperatives I want to share with you is this idea of inspiration and education, which is a real keystone of the Living Building Challenge, and in some ways it embodies all of the others. It says that it's not just about this building, but you should inspire other project teams to want to emulate these achievements. So what are you doing that helps educate others about your project? Now, this is a really high bar. There's no doubt about it. And when this first, not just this imperative, the whole system, when this first came out, a lot of us were really skeptical because we're saying, look, we've got to make a huge difference in a lot of buildings, and this is just too high. But we've all changed our tune because we think there's a place for raising the bottom, raising the bar for a lot of buildings, and also aiming really high and showing what is possible. So although there are not a huge number of buildings that have achieved full certification, I think what's really interesting is watching the growth. So a couple years ago, this slide had these 12 buildings, and I just looked up this morning, and there's now 24 buildings to date that have achieved full certification of all the petals. But remember, I said that you can also do petal recognition, and that's where you have to just meet 3 of the 7 categories, but at least one of those has to be what are considered the most important, which is energy, water, or materials. And so a couple years ago, I had 12 buildings in this slide, and I looked this morning, and there's now been a 9-fold increase, and there's over 100 buildings that are meeting this petal certification. So there's 3 types. There's the full, there's this petal certification, and then they created the net zero energy building certification. And that's where it must meet the imperatives, not only the net zero energy imperative, but it also has to meet these other imperatives that I didn't go into detail: limits to growth and rights to nature, which is a lot about access to air and sunlight and biophilic design, and the beauty and spirit I mentioned. And there's 37 projects that are now net zero energy building certified. That doesn't mean that these are the only net zero energy buildings out there. There's a lot of net zero energy buildings out there. They just didn't need this label. And there's 7 buildings just in the Bay Area. There's 5 shown in this slide. But I will say that there's a lot of transparency on the ILFI, the International Living Future Institute website. They have case studies about every single building that has been certified at different levels. So if you want to learn more, I encourage you to check that out. It's a really great website. So I will pause again for any questions on the LBC before I move on. None? Last chance. 5, 4, 3. Oh, there we go. Okay. What was the name of the website again? So International Living Future Institute, ILFI. It might be ilfi.org. Any priority for the petals? Well, if you're getting full certification, you have to do everything. If you're getting petal certification, it's considered that energy, water, and what was the other? Energy, water, and materials were the 3 important ones. I think, was that it? Energy, water, and materials. And then one more question before I move on. When people talk about NZEB certified building, is this what they're talking about? Great question. So when they're just saying my building is NZEB or it's net zero energy building, you need to demonstrate that it is through measured data. There are different ways to get certified for NZEB, but if they're referring to NZEB certification, they might be referring, and most likely, to this one. And Jacqueline just posted the link. Thank you very much for that. All right, with that, oh, look at that. It is quiz time. All right, so here's what we're going to do. I'm going to stay on the slide for a moment so everybody can take a deep breath. All right, you've seen how we do this before. We're going to have 6 questions. In a moment, I am going to say start. And when I say start, there'll be 12 minutes total. Very, very important. I want you to look at that last bullet. The way this system works is you cannot go backwards. So you want to make sure that you've thought about your answer before you submit and go to the next question, because you can't go back. To get to the link, open up a different browser and then come back to this when you're done. All right, there's going to be, you go to the syllabus, week 11, April 8th, that's today. There's a link for quiz 5. If you open it up, you'll see the front page, but you won't be able to move forward unless until we say start. If anybody is freaking out and can't find a link, send me a chat. Otherwise, we're going to start in a moment. And then also, if you have technical difficulties during the quiz, I want you to please send a private message to Carrie Hartigan, because she is monitoring the quiz, not to me. So I'm not seeing any chats. Carrie, are you getting any chats with people?
The quiz is
difficulties?
It's
open?
The quiz is not yet open because we haven't said start. And
Right. Okay. So I was waiting. I wanted to give everybody a chance to text to say a link isn't working. I'm not seeing it. All right, go ahead and start. And Carrie, you can holler.
I will.
It's open.
I will tell you when it's actually open.
Yeah. My start.
Yeah.
We're still figuring this out. When I say start, that is for Carrie to unlock it, and then she will actually say it's unlocked. We're figuring all this out.
All right, the quiz should be open now.
Okay, thank you, Carrie. Good luck, everyone. Carrie, are we locked?
Yep.
Okay, so questions may have been in a different order, but the question about illuminance, the answer is false. So remember, I used the trick of luminance. L starts with L, is about leaving the surface, and illuminance starts with I, and so that's incident on the surface. So that's a really good way to remember. This question about an overcast sky is true, that it's much brighter at the top than at the horizon, and that's important for thinking about skylight design in overcast climates. Which of the following is the least effective? The answer is A, the light structure with daytime ventilation. Remember, there's a lot more options for passive cooling in a dry climate, and all of the others work well there, but the daytime ventilation is really best for bodily cooling in a humid climate. Evaporative cooling strategy, spraying water is less effective. That is false. Remember, we talked about the surface area is important. So for the spraying water in the air, the surface area of every droplet is what's affecting the rate of evaporative cooling. This was from Stett's lecture. Drum roll, the answer is XPS foam. He talked about it, he showed graphs, and without a doubt, that was just over and above, had the highest embodied carbon, evil material. And then finally, this is also from one of the graphs he showed, as a building becomes more energy efficient, embodied carbon becomes a larger percent of the building's total emissions, and this is true. The total carbon emissions from a building is its embodied carbon when it is first constructed, plus its operational carbon over the lifetime of the building. And the more energy efficient, the larger the percentage of that embodied carbon in the beginning. Okay, let's move on now. I wanted to describe a little bit about the Bullitt Center, which is the largest building to date, I understand, that has gotten full living building certification. And Rob Pena, our speaker on the second daylighting project, was heavily involved in this. He talked about it a little bit, so I just wanted to tell you a little bit more. This diagram, I'm not going to go over in detail, but I'm showing it to inspire you to look at it on your own. I think it's one of the more, just cohesive ways I've seen somebody try to present the way in which the strategies in a building are organized. So this one looking at life cycle, water, energy, and occupant issues, and some of the systems at different scales. So this is a really nice way of organizing data and strategies. Maybe that's something that you can be inspired by. As well as this one, you see a lot of diagrams from projects about talking about the systems in a building, and this is also one that I think was really well organized by breaking it down into the heating and cooling, the envelope, the energy, and the water conservation. So for this building, it's getting all its energy either from the sun, hitting the photovoltaics on the rooftop, which is what we'll be talking about in a moment, and it's also got a geothermal system for generating heating and cooling as well. So just a quick little visual tour of the building. This is the top of the roof, the photovoltaics. You see the fabulous skyline of Seattle in the background, a rare day of clear skies. You can see some of the openings for skylights in this picture. And then moving to an interior shot on level 1, this is what's called Discovery Commons, they call it. And this is really dedicated to education and outreach. They do a lot of workshops and tours in this building. So the wall on the right is this wonderful collage of time series photos from the construction of the building. And the large vertical panels that you see on the left are describing the design and operational strategies for energy, water, and materials. So this is part of the educational aspect of this building. This is up above. The mezzanine that overlooks the lobby is the Integrated Design Lab, which is a research and consulting group that's associated with the University of Washington, and they help design teams with creating high-performance buildings. highlighting a few of the strategies in the building for energy conservation. The first way to approach energy conservation is to make sure you have a really good high performance envelope. And there's an interesting story that I want to tell you that from this picture, that if you look at the outer part of the envelope is the rain screen, that's the cladding, and then you have a gap behind it. But that orange material, that's a material made by a company called Prosoco, and it's a liquid applied membrane that serves as both a water vapor, water barrier and an air barrier. So it's replacing Tyvek. And Tyvek is very effective in terms of its performance, but it's got some red list material chemicals in there that they didn't want to use. So they found this material, and it was better, but it still contained a few of the red list materials. So here's the thing about the Living Building Challenge. What they tell you is that if you cannot find a material that forms the function, that serves the function you need, that if you go out of your way and you make sure you write to the manufacturer and you tell them that you want them to reformulate that, and you either, your first thing is to either try to find a product that meets the specifications. If not, you try to get the manufacturer to change their product. And if none of that helps and you can document your efforts, then you can request an exception to use that product. Well, that's what they did, but in this case, the manufacturer did decide to reformulate. And the first application of this new product is on this building. And now what's interesting is it also benefited the manufacturer, because now they can market this material as a product that meets LBC certification. So this is a great example of market transformation. So another aspect of energy conservation was being able to use natural ventilation. And they had a really interesting window treatment in this building, that these are really large 4x10 triple glazed windows. And you could see they're popping out. They had this parallel opening that instead of having a hinge, it has hinges around the whole building, so it pops out parallel to the facade. So why is that a benefit? Well, a few things. One, when it closes, you get this really tight, even seal across the entire perimeter, as opposed to casement windows that angle. It also allows you to open the windows when the blinds are down. And it also allows you to better utilize buoyancy-driven flow for stack ventilation when there's not a lot of wind pressure outside, because you can have air that comes in the bottom and then out through the top. This is actually a picture that I think Rob showed of one of the interior spaces, showing the inside of those windows and also the skylights. You can see the really deep light wells. So there's actually a relatively small opening and then a much deeper well. So the opening of the glazing on top is much smaller than what you see as the opening in the ceiling. And you can also see a deep well that allows the light to reflect and be diffused and better distributed throughout the whole space. So that's a nice strategy you might consider in your projects. And then I believe Rob showed this picture as well with the automated exterior blinds. Now, while fixed shading is more durable, and that's what we're teaching you how to do in ARC 140, in a climate like Seattle, where it's really overcast on a day that you want to get a little bit more view, and it's really nice to get those completely out of the way. So, and aesthetically on the outside, they really liked that it gave a very dynamic quality to the exterior facade and really changing its texture. So the mechanical system, one of the things that this and a lot of net zero energy buildings do is they separate the ventilation system and the thermal system. So for their thermal system is radiant, and this is showing all of the PEX tubing in the floor. They also have a really large system for rainwater collection. So the Bullitt Center gets 100% of its water from rainwater collection, which on one hand is pretty extraordinary for a large urban office building. And you imagine it's got a relatively small roof compared to the number of floors, but it is Seattle and they get a lot of rain. So what you're seeing here is what's called the day tank, which is the purified rainwater. So behind the wall are 56,000 gallons of collection in a cistern, and then the rainwater gets collected in the cistern and it goes through a bunch of different layers of a filtration system, and then the highly filtered water is in the day tank, and that's what needs to be used on a daily basis. It also has a really sophisticated waste management system. These are composters. It's an aerobic digester system. And each of these, it's really hard to see scale. So I wanted to show you this picture. Each of those blue tanks is the size of one of these little Fiat 500 clown cars, and there's 10 of them. And the way the aerobic composters work is that you need fuel, heat, and air. So the fuel is coming from us, it's the toilets. The heat is coming from the toilet paper, and they throw wood chips in there, and that breaks down, and as that's breaking down, it releases heat. And then the air that's needed is actually coming from the bathrooms itself. So the bathrooms are the only space in the building that has mechanical ventilation. It has operable windows as well, so the air comes in through the windows, and then the return air goes down through the toilets and into the composters, and that's what keeps the odors going down. So I wanted to talk about the energy performance of this building. And the first graph I want to show you is a comparison of the EUI, that's the energy use intensity, of a typical building of that size and that climate. And the colors represent the different kinds of loads in a building. So this may be typical that about 3/4 of the load might be for the systems and the heating and cooling and lighting, and 1/4 of it might be, or less, might be the plug loads, which is from occupants. Well, they had to set a target, and I'll show you why they had to set this target, for only 16 EUI. So they had to achieve over 80% savings in this building. And one of the things you'll see as I zero in on that is that as you get the building more and more efficient, the percentage of that building's load that is represented by the occupants is much bigger. So we'll see in a moment that in order to achieve that 16, because the percentage for the occupants was bigger, they really had to pay a lot of attention to those plug loads. So I want to talk a moment about process, because the process needs to be really different in a building like this. So there's two main questions you're asking. What can be supplied? How much roof area and how much PV do you have? And what's being used, right? So how much a building is using in terms of energy. And in most processes, number 2 would go first. But in this process, the step number 1 needed to go first. And I'm going to show you why. That if you started with number 2 and you said, well, how much energy is this building going to use? And therefore, how much roof area? This is what would happen. So let's start with, first I want to point out that I just showed you a graph where a typical building said 92 as the typical EUI for a building of this size. This was a different phase of analysis, a different group. They came up with 72. Don't worry about that. The actual number doesn't really make a difference. But if a typical building used 72 kBTUs per square foot per year, that means in order to generate that, you would need 64,000 square feet of PV, but the building is only 10,000 square feet. So that means that would be 6.5 times the footprint of this building. That's just not going to be possible. So they started with a typical, and then the analysis team said, all right, well, that may be typical, but a lot of typical buildings did not comply with current code. Remember, the floor kept raising. So what's the current code require? And that was 41. Well, that got a little bit better, but that PV area required would still be 4.5 times the area of the building. That's not going to happen. They said, all right, well, what if LEED was our criteria? what would, if we were going to achieve LEED Platinum, what would we have to do? Well, that lowered the EUI to 32. Still, you're almost 3 times the footprint of the building. So at that point, they're going, all right, we can't use these rating systems or codes to set our target. We have to flip the whole process around. What if we started with the question, how big is the roof? How big of an overhang can we have? And then we look at, all right, well, if that's the area that's available, how much energy can we produce and how efficient does our building need to be? So that's what they did. They have a 10,000 square foot footprint. They got permission to have a hat that was larger than the footprint, but still somewhat reasonable, 14,000. They looked at, for that area, how much energy could be produced and figured out, well, we have to create a building that is only going to use energy at the rate of 16 kBTUs per square foot per year, because that's the only way we're going to be able to achieve net zero. So that's how they got to this target number of 16. The next step is to figure out how to get to 16. All right, so now we're working with a different team, the same team that came up with the 92. Don't worry about that. That's not as important. I just want to go through the steps. So if you remember that inverted triangle that I've shown a few times in class, so the first steps are reduce the loads of the building. All the stuff we're doing in 140. How do you do a high performance envelope? How do you use passive cooling? How do you, and then they were also looking at, all right, how do we now make our systems, after you do that, how do you make our systems more efficient? And after doing all of that, they got the EUI down to 42. Not enough. Now they focused on lighting. How do you maximize daylighting? The kinds of things we're talking about in this class. How do you have controls to then minimize the electric lighting power? Got that down to 32. They still had to split that in half. And that's where that last bar, they had to look at all of those blue parts of the pie chart I showed you. What are we going to do about the plug loads in the building? What are we going to do about occupant behavior? How do we minimize use of elevators? How do we control what kinds of computers they bring in, since laptops use so much less energy than desktops? How do we control phantom loads in the building, the amount of energy that appliances are still using even when you think they're not because you've turned them off? And all of those things, they got it down to a target EUI of 16. So how's the building actually operating? Let's take a look at that. It actually did really well in its first 3 years. So what you're seeing here is the orange line is how much energy was being produced by that hat of photovoltaics on the top. And just like any building, you could see it's producing more in the summer. It's producing less in the winter. Remember that a net zero energy building is not about zero energy at any given time. It's about being at least net zero over the course of a year, generating at least as much as you're using. So the building is connected to the grid. It's not off the grid. It just means that when you have a surplus, you're selling back to the grid. And when you have a deficit in the winter, when you're using more for heating, for example, then you're able to produce. So the blue goes up, you're using more, and it becomes more than the orange line what you're producing. Then you're buying back from the grid. But this was 60% net positive over 3 years. If you look below the graph, the actual measured EUI of the building was less than 11. So it was even lower than the predicted 16. So this building did really well, and it's a great example of a large living building challenge. All right, so I am going to pause. I see a couple of questions. At what phase of design operation do you request an acceptance to use a material that falls on the red list? Oh, that's a really good question. So earlier the better, because you're specifying materials pretty early. It's way before operation. It's at the design stage. You can't even bring materials onto your site unless you've demonstrated that it's not on the red list. So this is going to be a very early stage of an LBC project. And then another question, can you buy energy from a renewable source off-site to reach net zero? A great question. Net zero is defined in different ways. For this particular certification, they're very stringent, and they want you to achieve using on-site renewables. So other kinds of certifications may be looser, and if you're buying energy from a renewable source, then that may be okay, but the more stringent requirements of net zero energy is about on-site generation. Great questions, Maya. All right, so I've got about 10 minutes left. I'm right on time here. So what I want to do is cover just a few kind of new certifications that are out there, and then give you an overview of one last system called the WELL certification. So ILFI, the International Living Future Institute, did develop the Living Building Challenge, and then they're also doing the Zero Net certification that I talked about, but they're developing a lot more. So they're developing the Living Product Challenge now, which is taking the rigor that's applied to buildings and saying, now you can actually get your product certified, and that will help people buy it. So it'll help the manufacturer, it'll help transform the market. They're also generating a lot of these transparency labels. So I talked about the transparency movement, and how the whole idea here is that if you just tell people more about what's in your products, then that will help help designers make better decisions, and it will help the manufacturers by saying, if you are going to be transparent about what's in your product, then maybe more people would actually buy it. So it's a little bit like the food labels on food products. We take those for granted now. Those didn't always used to be there, kids. Back in my day, you just had to just buy something and you didn't know what was in it. Now you can at least see what's in the products, and you make your own decisions about what's important to you. So I'm going to go through a few of these. Declare is something that is for products, and it's not just what's in it, but it's also where did it come from, and where does it go at the end of its life. There's also a label for buildings. There's been a lot of push that buildings should actually be required to claim every year what is their energy performance. So if you're selling a building, you're renting space in your building, you should be transparent about that building operation. So that's what the Reveal label is doing. It's like, if you're stepping up and you're saying, I do want to be transparent, how do I do it? How do I tell people? That's what the Reveal label is. So it has the EUI, which is a metric we talk about a lot in this class. There's other metrics out there. There's ZEPI is a Zero Energy Performance Index, which is about how close did you get to that zero energy performance. It's talking about percent difference, and it's also talking about the Architecture 2030 Challenge, and if you've met those. And then something that I think is really cool is there's now a transparency label for companies. So it's got all of these wonderful features. You see this checklist here. There was a company in Oakland, a couple companies in Oakland, Integral Group, and another one, a bank, I think, that were the first buildings to get the JUST label. So Bay Area has really been pioneers in this area. So it's a nutrition label for your organization. How are you treating your employees, right? Where do you invest in charity? What are you doing in terms of environmental stewardship? So that's actually pretty cool. There was a question, can a public entity get JUST certified? I have no idea. It's for, I don't see why not. It's for organizations and companies. I don't think there's any distinction between public and private. All right, so in the last little bit I have here, I just want to introduce you to kind of the new kid on the block, which is the WELL Building Standard. And this is a standard that is all about the people. It's all about trying to create an indoor environment that is good for us, for human health and well-being. And it took a long time to develop. It's very evidence-based. And Sarah actually had a quiz about this. It's estimated that we spend about 90% of our time indoors. So as you can imagine, the quality of the indoor environment can have a really profound impact on our health and well-being. And there's been a lot of studies that look at, I referred to worker recruitment and retention. There's been studies that ask people about job satisfaction and the quality of the indoor environment and the physical design. In several of these studies is identified as some of the top factors that impact people's satisfaction with their job. It's not just the work itself, it's the workplace. So it's really not in competition. WELL and LEED are designed to go together. The LEED has a small part of its credits for indoor environmental quality. So I would say that just like the Living Building Challenge is almost like LEED in its entirety on steroids, WELL might be taking just the indoor environmental quality piece and really blowing that up. And just like LEED, it's using GBCI as a third party to do certification, right? So they create the International WELL Building Institute, IWBI, creates the standard. They do a lot of education, and they also then turn things over to the GBCI to do the certification. Now this slide reminds me, I had an announcement earlier in the semester, so I encourage you to browse through my announcements. And IWBI was looking for students for summer internships. And this is actually a fabulous organization. They're in New York City, which you wouldn't want to go to now, actually. Huh. Maybe, maybe they're delaying this internship. Anyway, check it out. It's a good organization to check out. They're in a new building that's both LEED Platinum and WELL certified. It overlooks the High Line. And one of the former 140 students got an internship there and then ended up getting a permanent job there. Kaylee, and she's the one who sent me the announcement. So check that out. So how is WELL organized? They also have categories, just like LEED and Living Building Challenge, but their categories are all about the people. So for air, it's all about air quality and toxicity. For water, it has nothing to do with water conservation or stormwater management. It's all about water quality and accessibility to clean water. Nourishment, do you provide food for your employees? What are the cafes in your building, and do they have healthy menus? Light, is there a lot of natural daylight, and are you supporting circadian health? Do you have opportunities for people to move, sit, stand desks, compelling staircases, fitness programs? Comfort, thermal comfort, it's not just about the environmental conditions, but what kind of controls do you have in the space? And then a lot of different credits for just sort of mind and spirit. And it's, you know, it's similar. I keep using the analogy of nutrition labels. So they have the scorecard where for each of those categories, you get checked for how well you're actually doing. And a little bit like Living Building Challenge, this is not about intent. This is about operation. And so the certifiers have to go into your building and see how things are actually operating. Similar to LEED, they have, LEED has mandatory measures. They call them preconditions. LEED has points. They call those optimizations. And so different words for the same concept, and they have those across all 7 categories. And also similar to LEED,
You can get certified at these different levels of silver, gold, and platinum. You can also, as a person, just like you can be a lead AP, you can be a well AP and demonstrate that you're familiar with this. And then my final slide here, I wanted to show you that, oh, I see a comment that well version 2 has 10 concepts now. Thank you, Alfonso, for reminding me about that. It is hard to keep up. I love it when my students know more than I do about something. Thank you for that. So my last slide here is that the IWBI, the International Well Building Institute, is working along with the Mayo Clinic. And this actually says Delos. It gets incestual. Delos is an organization under which IWBI was formed. I think they're trying to split apart and put a firewall between them, but they're really not doing very well. So I continually get IWBI and Delos mixed up in terms of when I'm talking about it. I apologize for that. But they've created this amazing facility at the Mayo Clinic. I'm on their scientific advisory board, and I have been so impressed with the work they're doing. It is the largest facility I've ever seen where they're trying to simulate real world conditions in carefully controlled laboratory environments. So you saw our little room. This is our chamber. This is like that on steroids. And what they can do is they can bring in people to work in there for months because it's set up as real office space. They've got spaces that are set up as residential living spaces that people can move in for months and be part of this study. And they are really doing amazing work. And in this last slide, I've got a link here to a YouTube video that they did a really nice job on giving you a tour of that. So they've just started up a couple years ago. They're building another one in China, and we're looking forward to a lot of good work coming out of that. So with that, the lecture is done. You can check out. Thank you very much. This continues to be so strange just staring at a screen. Thank you for your patience with all of that, but I will stay on the line if people have some additional questions. So thank you. And you can also unmute yourself if you want to talk to me. That'll work too.
Thank you.
Thank you, thank you, thank you.
Thanks, Gail.
Thank you, you're welcome.
Thanks, Gail.
Stay well, everybody. Crazy times, stay well, stay well. Happy Passover to anybody who's celebrating tonight, as I am. All right, I'm going to shut things down. Many thanks to all of you commenting with your thanks and attitudes of gratitude. I appreciate it. I miss you all. Bye-bye.